I'm Eric Amador. I work in the Department of Physics for Dr. Wei Chen. I'm a graduate student, and here I would like to present on a new synthesis protocol for producing highly monodispersed copper sestamine nanoparticles. And here, what we want to do is be able to apply nanoparticles for photodynamic therapy. In order for us to improve this photodynamic therapy, which uses a nanoparticle that absorbs light in a certain frequency, along with light activation, we would like to apply this to kill cancer cells. We improve this monodispersion in order to improve the cancer-killing effect of copper cystamine. However, this new approach uses oleamine and oleic acid, which are going to make the nanoparticle hydrophobic instead of hydrophilic. So there is a trade-off. However, our results give us highly monodispersed nanoparticles, as seen with these TEM images. In Figure 7, we have a average size of 20 nanometers in diameter, and depending on the precursor concentration, you can control the dispersion of the nanoparticle. So for really high concentrations, you can produce very highly monodispersed nanoparticles, as seen in Figure 7, or if you have very low concentration of copper and cystamine precursors, you will get larger nanoparticles. And the main objective is to be able to use these nanoparticles in cancer cells, as we've done in previous publications, such as in these three images where we have copper cystamine by itself, microwave only, being applied to the cancer cells, and both of them being used in unison to kill the cells. So this previous publication is what's driving this new synthesis method. And we also produced, we also found a way to make it hydrophilic, which was to oxidize the alkene bond on the oleamine and oleic capping agents. And we did this by mixing CuCy or copper cystamine in a organic solvent such as chloroform, and then adding potassium permanganate in order to oxidize this alkene bond. Once we did this reaction, we verified using FTIR to see the hydroxyl functional groups on the surface, and we compared it to before and after the oxidation. We also varied the oleamine to oleic acid ratios and observed that there was a slight increase in the peak of the copper cystamine nanoparticle, which led us to believe that maybe there was an enhancement in the quantum yield, but it does vary it, but it did not improve on the previous synthesis method. But these are the images of what the nanoparticle looks like under UV light and under normal room light. In conclusion, we were able to make a new highly monodispersed nanoparticle and of copper cystamine, and we plan on using it for a number of things, such as wastewater treatments to decompose perfluoroalkene, which are forever chemicals, and also to see if we can enhance the cancer-killing effect using photodynamic therapy. So yeah, thanks.